Hello, welcome back. Here we are, 5.3. We are going to be doing our operations with these polynomials. So we're going to add, subtract, multiply, and divide our polynomials. The only really new operation in there is division. So that's what we're focusing on, is dividing the polynomials. But we want to start off with a review of adding, subtracting, and multiplying, and even a review of composition. So here we have f of x is 3x squared minus 2x plus 1, g of x is 4x squared minus 5, and h of x is 7x cubed minus 3x squared plus 4x minus 5. So these are just three different functions that I'm providing to you. And so we're going to go through each operation here. So what we see first is g plus h of x. Well, we know that's the same thing as saying whatever g of x is plus whatever h of x is. Okay, first thing you need to do is understand the notation given, okay? So we're adding those two functions together. So I'll just keep that there. So I'm going to take my g of x, 4x squared minus 5, and I'm going to add my h of x function, 7x cubed minus 3x squared plus 4x minus 5. Because it's a positive, because we're adding, we technically do not need to put parentheses around the function. However, if that's going to make you feel better, you are more than welcome to do so. Okay, so I'm not going to put them because I don't need them, because I'm just adding. None of my signs change. So at this point, all I'm doing is I'm combining like terms. And I kind of want to do two steps at once. I'm combining like terms, but I also want to write it in standard form. I want my answer to be in standard form. That means whatever exponent is the highest, that term goes first. Well, looking at what I have, my highest exponent is 3. So that 7x to the third power is going to go first. So I'm taking care of this guy. If you want to kind of write it in a different, let me do this. Let's go green. Can you tell the difference there? Let's do that one. Okay. So 7x cubed takes care of this guy. Aw, there, this guy. Then what's after cubes would be squared. So I see a 4x squared and a minus 3x squared. So the 4x squared and the minus 3x squared give me a 1x squared. Then I go to x. I see a positive 4x here. And then I see a minus 5 and a minus 10, which combine to give me, minus 5 give me minus 10. So my answer, my sum is 7x cubed plus x squared plus 4x minus 10. All right, now we're going to do f minus h of x. So as you can tell, that is taking the f of x function and subtracting the h of x function. Very, very, very important that you're going in order here. You cannot flop these around. That would be a totally different answer. For adding, you could, and it wouldn't be a big deal, but for subtraction, it would definitely change. So we want f of x, which is 3x squared minus 2x plus 1, and we are subtracting this entire function of 7x cubed minus 3x squared plus 4x minus 5. Notice minus 5. Okay. Notice I put that in parentheses because I am going to have to distribute that negative. I am subtracting every single term in that function. So what I'm going to do is rewrite that step. I'm going to say this is 3x squared minus 2x plus 1 minus 7x cubed plus 3x squared minus 4x and then plus 5. And so then now I want to write it in standard form, negative 7x cubed plus 6x squared, boom, boom, minus 6x, and then plus 6. And there we have it. Okay. Now we're going to go to multiplication. So multiplication, we're doing f times g of x. I need you to look at the difference between c and d. C is multiplying f of x times g of x. D is composing g of x inside of the f of x function. A lot of y'all messed that up last time, so please be careful here. Look at the difference of the notation. Okay, so f of x is 3x squared minus 2x plus 1. G of x is 4x squared minus 5. Okay, I put them in parentheses. It just helps me. You don't have to, but I would suggest it. And at this point, I'm really kind of just like double distributing or triple distributing, however you want to call it, based on which way that you wrote it. You know that multiplication is commutative and associative and all those things. So again, it doesn't matter if I would multiply f to g or g to f. We would get the same result. So I'm just going to work from left to right. So I'm going to distribute that 3x squared to both of those terms. Then I'm going to distribute the negative 2x, and then I'll distribute that positive 1. If you want to go the other way around, that's totally fine. Oops. Okay, so 3x squared times 4x squared is going to be a 12x to the 4th. Remember, when we multiply terms with exponents, we add the exponents. 3x squared times negative 5 is a negative 15x squared. Negative 2x times 4x squared is a negative 8x cubed. Negative 2x times negative 5 is a positive 10x. 1 times 4x squared is 4x squared, and 1 times negative 5 is negative 5. And then, of course, we're going to combine like terms and write it in standard form. So that was going to give me 12x to the 4th minus 8x cubed. That is going to be a minus 11x squared plus 10x and a minus 5. All right, and lastly is our composition. So g of x is going inside. That is the input to our f of x function. So I start with my f of x function, and everywhere I see an x, I'm going to replace it with g of x, that entire function. So 3, I see an x. Open a parenthesis, write your whole g of x function. That is squared because I was squaring that x. Minus 2 times, and then plus 1. So what I need to do first is I actually need to FOIL this binomial before I distribute the 3. Order of operations. Okay, parentheses, exponents, multiplication, division, addition, subtraction. Parentheses, nothing can happen inside of there, but then exponents, I can square that binomial, so I do need to do that. Remember, squaring a binomial, squaring this binomial in particular, would not give me 16x to the 4th minus 25, or plus 25, okay? You have to FOIL it out. So if I rewrite that in FOIL, this would give me 3 times excuse me, first times first, so that would be 16x to the 4th. Outer would be a negative 20x squared. Inner would also be a negative 20x squared. And then the last would be a positive 25. And then I'll make this a little bit smaller. If you want to distribute for that next one, you are more than welcome to. Or you can just rewrite it. I might just distribute negative 8x squared plus 10 and then plus a 1. And so now I need to kind of combine like terms and distribute that 3. So combining like terms here is just going to give us a negative 40x squared. So I'm going to go ahead and erase that. Negative 40x squared. All right, so then I need to distribute the 3. So 3 times 16 is going to be 48. Is that right? 3 times 10 is 30. 3 times 6 is 18. 30 and 18 is 48. So this is going to be 48x to the 4th minus 120x squared plus 75 minus 8x squared plus 11. And then I can combine it one more time. So it's going to give me 48x to the 4th minus 128x squared, and then plus 86. Okay, so big difference between composition and multiplication. So we've added, we've subtracted, we've multiplied, and we've composed. Adding is pretty straightforward, so is multiplying. with subtraction, you just want to make sure that you distribute that negative to everybody, and then just remember the difference between composition and multiplication. And so now we get to that division, which I said is going to take up majority of today's lesson, just because that is kind of, I wouldn't say the hardest, but it's probably more challenging than adding and subtracting and multiplying. But if we remember how to long divide just numbers like we did back in, third, fourth grade or whatever, it really is the same process when you do it with polynomials. So let's practice that first. Let's kind of get that process back into our brain, if you will. So if I wanted to long divide numbers, I want to do 31,272 divided by 5. Well, one thing that we already know is that it's not going to be evenly divisible. So we are going to have some kind of remainder to this division problem. Our divisor here is 5. That is what you're dividing the dividend by. Our dividend is 31,272. So divisor, what you're dividing by. Dividend, what is being divided. And then, of course, the answer to that division problem is our quotient. And because this is not evenly divisible, we know we're going to have some kind of remainder. So if you were dividing this problem, you would first say, can 5 go into 3? No. Can 5 go into 31? Yes. How many times can 5 go into 31? 6. And then you do, what is 6 times 5? So that part of the quotient times the divisor gives us 30. Notice you marked the 30 down, and then what did you do? You subtracted, right? And after you subtracted, you then brought down another number. Because 5 didn't go into 1, but now that I brought down the 2 in the dividend, I'm going to say, well, how many times does 5 go into 12? Well, 5 goes into 12 2 times. Notice how the 6 is on top of the 1 and the 2 is on top of the 2. I mean, it's not, I don't know. To me, I think it's really important to keep everything lined up, just so we don't get lost or confused in our numbers. So just try to be really neat with this. And then, of course, we multiply back. 2 times 5 is 10. So I write it down and then I subtract. That gives me 2. 5 does not go into 2, so I drop down my 7. How many times does 5 go into 27? 5 times. What's 5 times 5? 25. What's 27 minus 5? 2. 5 doesn't go into 2, so I drop down my last 2. How many times does 5 go into 22? 4 times. 4 times 5 is 20. Left over of 2. There's nothing else to add on, but most of you say, well, then you do your decimal 0. How many times does 5 go into 20? Here's where it's really important that everything stays in line. And then most of you would have said 4. So our answer is 6,254.4. And that's totally fine, right? However, when we're dealing with polynomials, we're not going to have a decimal of a polynomial. We're going to have a fraction of a polynomial. So we know that 0.4 is 2/5, right? So this is 6,254.4 or 6,254 and 2/5. Now, you're thinking to yourself, well, I know that 0.4 is 2/5, but how would I know what the fraction of the polynomial is? It's the same thing, guys. Think about it this way. If I didn't add that decimal, what is left? 2 over 5. 2 over 5. So that remainder over the divisor is that fraction. How cool is that? Okay, so this is going to be very useful, very helpful when we go to divide things like example 2 and example 3. And you might look at that and say, oh my God, that's okay. We know how to do this now. It's the same method that we do for numbers, okay? So let's try that out. We're going to go slow, okay? So we are doing 4x to the third plus 2x squared plus 3x plus 5 divided by x squared plus 3x plus 1. First things first is I would always rewrite this as a long division problem. So my divisor is x squared plus 3x plus 1. My dividend is 4x cubed plus 2x squared plus 3x plus 5. Now, I will say here, it is going to be very helpful to you if your if your dividend, what is being divided here, your dividend has every single term. What do I mean by that? I mean, it has the cubic, the square, the x, the constant. Because not all polynomials have every single term. You could have something of x to the third plus x minus 1. Well, where's that x squared term? It's missing. If you're missing a term, it's actually really easier to put a 0 in its place. So getting in that habit is actually a really good thing to do. We don't need to do it for this particular problem, but we may need to do it in the future. So here we go. Just like numbers, we actually just take the first term of the divisor and see how many times it goes into the dividend. So all I'm worried about right here is taking x squared and seeing how much, or dividing it into 4x cubed. Well, how many times, quote unquote, does x squared go into 4x cubed? Or thinking about it as 4x cubed divided by x squared. Well, what's 4 divided by 1? 4. What's x cubed divided by x squared? Just x to the first power. Remember, when you're dividing things with exponents, you subtract the exponents, okay? So this is actually just 4x. So now what do? I take that 4x, part of the quotient, and I multiply it to everyone in the divisor, not just the first term, but everyone. So 4x times x squared is going to give me 4x cubed. Pause right there. If you're doing long division correct for polynomials, when you multiply this part of the quotient to that first term, you should always get the same term, that first term back that was in your dividend, okay? You always want to be able to subtract and get 0 at that point. Okay, so keep going. Multiply the 4x times x squared to get 4x cubed. Multiply the 4x times 3x, get 12x squared. Multiply the 4x to 1 and get 4x. Now, what did we do with our numbers here? We actually subtracted. Well, remember, when I subtract polynomials, I need to distribute that negative to everybody. So what I like to say here when I'm doing polynomial long division is, at this point, I am going to draw the line, change the signs. Because if I'm going to be distributing a negative, every single sign is going to get flipped. If it was negative, it will be positive. If it was positive, it will be negative. And so now I go through and combine. These should always cancel out to 0. Okay, and if you need to put the 0 there, you can. What is 2x squared minus 12x squared? Well, that's negative 10x squared. 3x minus 4x is negative x. And then I do want to drop down that positive 5. Okay, so now I do it all over again. Again, only the first term. How many times, or what is it? What is negative 10x squared divided by x squared? Well, negative 10x squared divided by x squared is just negative 10. So negative 10 goes at the top. Now I take that negative 10 and I multiply to everybody in the divisor. So negative 10 times x squared is negative 10x squared. That's a good thing. We should be getting the same exact thing back. Negative 10 times 3x is a negative 30x. And then negative 10 times 1 is a negative 10. Draw the line, change the signs. Always cancel out, making it 0. Now this is going to be 29x and plus 15. And notice my next step would be, how many times does x squared go into 29x? Or can I do 29x divided by x squared? And the answer to that is no, you cannot. Okay, so this is where my answer stops. So my quotient is 4x minus 10. But clearly I have a remainder of 29x plus 15. So as we talked about earlier, how do we write that answer? 4x minus 10 plus our remainder over the divisor. It's always going to be a fraction if you have a remainder. Okay, so always add that fraction of the remainder. Even if this was a negative 29, we would add negative 29x plus 15 over x squared plus 3x plus 1. Okay, but it's not a negative, so we leave it. All right, you just did your first polynomial long division problem. Congratulations. Let's try it again. Let's go here. Okay, first thing I want to do is rewrite it in long division kind of format. So x squared plus 2x minus 5 divided into 6x to the 4th plus 5x cubed. Notice there's not an x squared term, so I would probably put 0x squared plus 2x plus 8. Not a huge deal right now, as long as you are very aware of the terms that you're combining. But you're going to see that some kind of division that we do later on, that it is absolutely imperative, it is necessary that you put a 0 as a placeholder. Okay, so here we go. How many times does x squared go into 6x to the 4th? And that would be 6x squared. Let me drag this down just a little bit. Okay, 6x squared. 6x squared times x squared is 6x to the 4th. 6x squared times 2x is plus 12x cubed. Notice that cubic is under the cubic. 6x squared minus times a negative 5 is a negative 30x squared. Notice if this wasn't there, it would be the 2x in its place, and then I would be more likely to combine a 2x with a negative 30x squared, but that's not possible, right? So at this point, it's really easy for me to keep all my like terms in order. So at this point, I draw my line, change the signs. Always should cancel out. 5x cubed minus 12x cubed is negative 7x cubed. A 0x squared and a 30x squared is a 30x squared. Drop down, drop down. Do it again. How many times does x squared go into negative 7x cubed? Well, negative 7x times. Negative 7 times x squared is negative 7x cubed. Negative 7x times 2x is a negative 14x squared. Negative 7x times negative 5 is a positive 35x. Draw the line, change the sign, cancel. 44x squared, that is now a negative 33x. Drop down the 8. Try it one more time. How many times does x squared go into 44x squared? Well, 44 times. 44 times x squared is 44x squared. 44 times 2x is a positive 88x. 44 times negative 5 is a negative 220. Draw the line, change the signs. Cancel. That is going to now be a negative 121x and a positive 228. I cannot divide a 121x or negative 121x by x squared, so I stop here. My quotient is 6x squared minus 7x plus 44 with a quotient of with a remainder of negative 121x plus 228 over x squared plus 2x minus 5. The end. All right. Now, we're going to try it one more time. Long division. This one looks a little bit simpler because look at that divisor. This was an x squared. This was an x squared. This one is just an x. So we think it might be a little bit easier here. And you're thinking you're going to be right. So how do we set it up? We have x minus 3 into 2x cubed minus 6x squared plus x minus 4. So here we go. How many times does x go into 2x cubed? Well, 2x squared. 2x squared times x is 2x to the 3rd. 2x squared times negative 3 is a negative 6x squared. Draw the line, change the sign. 0, 0. Okay, so then that means drop down the x, drop down the negative 4. How many times does x go into x? 1 time. 1 times x is x. 1 times negative 3 is negative 3. Draw the line, change the sign, cancel out, negative 1. So my quotient is 2x squared plus 1 plus the remainder of negative 1 over x minus 3. There's our division problem. However, because, like I said, this one is a little bit easier, there's actually, I don't want to say a shortcut, but a different method of dividing, and it's called synthetic division. Synthetic division. Synthetic division will only work, please listen to me, will only work when your divisor, right? When your divisor is just x plus or minus a number, okay? X minus a, x minus negative 2, x minus 7, x minus 1, x minus negative 4, okay? Only that one x, not x squared minus 10, not x cubed plus 11, only x plus or minus a number. Okay, so it says dividing by x minus a with synthetic division. That a value is going to go in the box in the top left corner. And I'm going to show you the structure of what we're talking about here. We're going to list the coefficients of the dividend and fill in 0 for any skipped terms. That's what I was talking about earlier. We're going to bring down that first coefficient. We're going to add down the column. And the quotient always starts with 1 degree less than the dividend. And as a reminder, we are always writing our remainder as a fraction over the divisor. So what does all this mean? What does all this look like? Well, we're going to use the same problem because we can. Okay, and we're going to double check that we're getting the same answer. It says a goes in the box in the top left. A, x minus a. So our a value is 3. I draw a horizontal line and then I draw a vertical line. So there's my box at the top left corner they were talking about. And then I also draw this horizontal line down here. So it's almost like a rectangle, almost like a hashtag, kind of a weird shape, but draw, like, write your number, horizontal line underneath it, vertical on the side of it, and then one across the bottom as well. Across the top here, you're going to write the coefficients of the dividend. 2, negative 6, 1, negative 4. There was no skipped terms, T-E-R-M-S here, so I don't have to put a 0 anywhere. Bring down the first coefficient. Boom. So 2. Okay, I'm going to multiply now. Just like I was multiplying over here with long division, 2 times 3 is 6. Add down the column. Negative 6 plus 6 is 0. Multiply. 0 times 3 is 0. Add down the column. 1 plus 0 is 1. Multiply. 1 times 3 is 3. Add down the column. Negative 4 plus 3 is negative 1. Now, this I also block off because I know that this last term in this top right corner here is going to, whatever number gets added to it is going to, this is my remainder, okay, always. So if you got 0 at that bottom right corner, that's a good thing. That means it was evenly divisible. If you didn't, then that's the remainder, so that's what you put over the divisor. So remember it said your quotient starts with 1 degree less than the dividend. So this down here is your answer, okay? We're starting with 1 degree less. So if our dividend was x to the third, well, if I divide by x, then obviously my answer, my quotient is going to be x squared. So this tells me I'm getting, let me make it a little bit smaller. This tells me I'm getting 2x squared. Technically, this is plus 0x plus 1 with a remainder of negative 1 over x minus 3. Did we get the same exact thing? 2x squared plus 1 plus a negative 1 over x minus 3? Yes, we did. A little bit easier, a little bit quicker once you get the hang of it. Okay, so remember, you can only use synthetic division when you're dividing by like a linear. It's x plus or minus a number. Okay, so let's try it again. We have two problems with in example 5, and it says use synthetic division. So we're trying to practice this process because it's new to us. So what is my a value here? I'm doing 2x cubed minus 5x plus 8 divided by x minus 2. X minus 2. So what's the A value? 2. Horizontal line, vertical line, horizontal line. Across the top here, I write my coefficients, and I want to make sure I put a 0 as a placeholder. 2x to the third, 0x squared, negative 5x, 8. I know my remainder is going to be here, so I also draw that vertical line just to help me out. You don't have to do that, okay? Process, drop down the first term, multiply. 2 times 2 is 4. Add. 0 plus 4 is 4. Multiply. 4 times 2 is 8. Add. Negative 5 plus 8 is 3. Multiply. 3 times 2 is 6. Add. 8 plus 6 is 14. So here's my quotient. Here's my remainder. Okay. So quotient always starts with 1 degree less. 2x squared plus 4x plus 3 plus a remainder of 14 over x minus 2. Done. See how quickly this can go once you're familiar with this process? Let's try one more time. Let's go here. Now, this one is written as a fraction. You can leave it, you can rewrite it, whatever you want. But what is the A value here? We're seeing x minus what number? Well, if you see x plus 1, then that means I'm minusing a negative 1. So you want to be careful with that. This is negative 1, horizontal line, vertical line, horizontal line. Write your coefficients at the top. 2x to the fourth, 0x cubed, negative 4x squared, 2x, negative 3. That constant column is always going to give me my remainder. Drop it down. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. So starting with 1 degree less, 2x cubed minus 2x squared minus 2x plus 4 plus a negative 7 over x plus 1. And there you have it. Really, really simple. Okay, so remember, for synthetic division, we can only use it when we're dividing by a first degree binomial, x plus or minus a number. Sorry, everything else is long division. When, this is pretty cool, the second bullet. The remainder, when dividing by x minus a, is the same thing as evaluating the function at a. Okay, so let's put this into perspective. Let's look at a and b here, because a had a remainder of 14 and b had a remainder of negative 7. This bullet point is saying the remainder when dividing by x minus a is the same as evaluating the function at a. So let's look at a, this a, sorry. When I was dividing by x minus 2, my a value was 2. It's saying the remainder of 14 is the same thing as taking this function and evaluating it at 2. So let's just try that out real quick. F of 2. Well, that would be 2 times 2 cubed minus 5 times 2 plus 8. Well, 2 cubed is 8 times 2 is 16 minus 10 plus 8. That's 6 plus 8, which is 14. Coincidence? No. Could try it again with, okay, good. Let's try it this time over here. Let's do purple. Here's our a value. Here's our remainder. Evaluate this function at the a value and you should get negative 7. 2 times negative 1 to the 4th power minus 4 times negative 1 squared plus 2 times negative 1 minus 3. Negative 1 to the 4th power is 1. 1 times 2 is 2. Negative 1 squared is 1. 1 times negative 4 is negative 4. 2 times negative 1 is negative 2 minus 3. 2 minus 4 is negative 2 minus 2 minus 3. That's negative 4 minus 3 is negative 7. Oh my God. How cool is that? I love that. I think that's so neat. Okay, so that's just a fun fact that we will kind of pose some questions about. Another thing that I mentioned earlier is obviously if the remainder is 0, then the divisor is a factor of the dividend. Well, that makes sense, hopefully. All right, so we have 2 more questions to do. First one says, given f of x is 4x cubed plus 3x squared plus 2x plus 1, evaluate f of negative 2 using synthetic division. So you've got to be aware of those directions there. So that is referencing the second bullet again, okay? If it's saying dividing by x minus a is the same thing as evaluating of f of a, then that means I want to divide by x minus a negative 2, which is really just x plus 2. Well, that's fine. I don't even need to write that out because all I need to know is up in that left-hand box is negative 2. 4x cubed, 3x squared, 2x, and 1. So here we have it. Drop down the first number, multiply, add, multiply, add, multiply, add. So f of negative 2 is equal to negative 23. You don't believe me? Let's try it the other way. 4 times negative 2 cubed plus 3 times negative 2 squared plus 2 times negative 2 plus 1. Negative 2 cubed is negative 8. Negative 8 times 4 is negative 64. Is that right? Negative 64? No. Yeah, no. What are you talking about, Mr. Reese? Shut up. Negative 4 times negative 8. What is 8 times? Oh, 32. Sorry, my bad. Whew. Negative 32. Negative 2 squared is 4. 4 times 3 is 12. Minus 4 plus 1. Negative 32 plus 12 is negative 20. Minus 4 plus 1. Look at that. Negative 23. Isn't that so cool? I just love that. Okay. Last one. Determine whether x minus 5 is a factor of x cubed minus 4x squared minus 7x plus 10. Well, that's using the third bullet point. So we can divide. 5. 1x cubed minus 4x squared minus 7x plus 10. Drop it down, multiply, add. Oops, that is a positive one. Multiply, add, multiply. So what does that mean? If we get 0 for a remainder, then yes, it is a factor. Okay. Congratulations, you know how to do different operations with polynomials, specifically long division and synthetic division, okay? Make sure you study 5.1 to 5.3 so we can do well on our quiz next class. Love you guys. Bye.